Okay, now we're going to use the information you had from the counting methods unit in probabilities. And this is one of the reasons why we do the counting methods, is because you have to figure out what are the different possibilities that could happen before you can figure out what the probability is. Okay, so in this case it says we have these three guys, Jamal, Ethan, Alberto, are competing with 7 other boys. So there are 10 people in the race. Okay, all the boys have an equal chance of winning the trial race. Determine the probability. The probability that Jamal, Ethan, and Alberto finish first, second, third. So that's what we're trying to figure out, the probability. Okay? Well, first of all, you have to figure out the number of possible outcomes. Okay? So the number of possible outcomes. Okay, so this is a little bit of a trickier question. It says, determine the probability that they will finish first, second, or third in any order. This means that we don't care if they finish first, second, or third. We just want to know how many ways can we have those 3 guys in the first 3 spots. So this is actually not a permutation question. Okay, because if it was a permutation question, we would say 10 permute 3, and there's only one way that it would happen. But I don't like this question for that, because it's not asking us to say all the different ways. It's just saying we just want those 3 guys to be in the front. So this is actually a combination question, because I don't care whether it's actually Alberto that's first or Jamal is first. I just want those 3 guys to be in the beginning. Okay, and so what I'm going to do here for the number of possible outcomes is 10 choose 3. Like, how many ways can I choose 3 people? And then there's only one way that's favorable. Okay, and that's of those 3 guys, I'm going to choose all 3 of them. This is actually going to be 1. Okay, so this is the total number of outcomes. This is the total number of ways to choose 3 people. But I don't want to choose just any 3. I want these 3. So this probability is going to be 1 out of 120. Okay, a little bit of a tricky start there to this lesson. Okay, let's try the next one. About 20 years after they graduated from high school, Blake, Mario, Simon met in a mall. Blake has 2 daughters with him. He said he has 3 other children at home. Determine the probability that at least one of Blake's children is a boy. Well, we already know the first 2 are daughters. So really we're only concerned with the 3rd, the 4th, and the 5th child. And we've already done this if we want to decide what could happen. So at home could be 3 boys, could be 2 boys and a girl, could be boy, girl, boy, boy, girl, 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 boy, boy, girl, boy, girl, 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 boy, and girl, girl, girl. That's what could happen at home. Okay, and the question says determine the probability that at least one of Blake's children is a boy. Well, all of these situations will give him a boy. Only this one would mean he'd have 5 girls. Okay, so what is the probability of at least one boy? Well, you can see that it looks like 7 out of the 8 gives him at least one boy. Okay? So that's using a sample space. Now it says use the fundamental counting principle. Okay, so again, we've got the third and the fourth and the fifth child. So there are, so I'm going to write third, fourth, fifth child. There are two possibilities here, two possibilities here, two possibilities here. So there are 8 possibilities. Okay, and we know that there is only one way to have girl, girl, girl. Is just one of those. Okay, so that would be 1 times 1 times 1 if we wanted 3 girls. Okay, so a girl, and a girl. So again, the probability of at least one boy, at least one boy, not boys, would be 1 take away the probability of no boys, in other words, all girls. So this is 1 minus 1 over 8, which is again 7 over 8. Okay, now, I mean, I just showed you 2 ways to do this, but you don't need to overthink this and try to figure out what's the correct way to do it. You need to use some common sense here and think about each question individually. Okay? Let's talk a little bit more of this at least once idea. At least once probability is the complement of the probability that the event will not occur. Okay, to determine at least once probability, we first calculate that the probability will not occur, and then subtract it from 100%. That's what we did up here. If we want at least one boy, that's like saying we want every other scenario except for no boys. So we go 1 take away no boys. Okay, so that's the complement idea. So this is the formula if you want to write this on your cheat sheet. If you want the probability that the event occurs at least once, you're going to see that again. That's 1 take away the probability that the event does not occur. Okay? So in the previous one, if you want at least one boy, you take away the probability that there are no boys. Okay? All right, let's look at this example. So Bo's got this contest he's going to come up with. He's going to take the letters in Saskatchewan, turn them upside down, and randomly pick someone to turn the letters over one by one. If they spell the word Saskatchewan, they win a new car. What's the probability that this will happen? What's the probability of winning? Well, first of all, we need to know how many ways can you pick out or arrange those letters. Okay, this is possible outcomes for probability. Now in this case, what do I mean by possible outcomes? This is the number of ways to turn over the letters. All right, and really favorable, how many favorable outcomes are there? Well, there's just going to be one favorable outcome. Okay, I mean, there's not more than one way to spell Saskatchewan. There's one way. So we're going to have 1 over. Now, how do you arrange the letters of Saskatchewan? Well, remember this from last unit. If you have 12 letters, that's going to be 12 factorial. Except that there are some repeats. Okay, there are 3 A's. All right, is there anything else that repeats? Okay, there are 2 S's. And there are 7 other letters. Okay, so this, if you want to write this 2S, and this is 3A, this will give us the probability of getting the favorable outcome. 1 over, well, this is a little bit of a crazy number. So 39,916,800. This is the probability of winning this car using this game. Okay. Last example for this lesson. Says there are 18 bikes in Marnie's spinning class. The bikes are arranged in 3 rows with 6 bikes in each row. Allison, Brett, Carol, Doug, Erica, Franco each call the gym to reserve a bike. They hope to be in the same row, but they cannot request a specific bike. Determine the probability that all 6 friends will be in the same row with Allison and Franco at either end. Wow, that's quite the question. Okay, so the probability, well, I'm not going to write that as the probability of this situation. What is it? Well, there are 18 bikes. 18, I mean, if we just do this randomly, there's 18 different ways that you could end up at a bike, and since they're all equal, there are 18 factorial ways to get on a bike. Okay, so now we need to figure out the probability of this description that's going on here. Okay, they hope to be in the same row, but they cannot request a specific bike. Okay, so let's put this scenario down here. Let's look at one row. It says that Allison and Franco are at an end. So Allison or Franco could be here, then the other one has to be here. And since all the friends want to be together, the rest of them, the 4 of them, would be here. So this is the number of ways that they could be arranged in a row. But the problem is there are 3 rows. Okay, so far we've got 2 factorial, that's 2 times 1. We've got 4 factorial, and we've got, this could happen, well, before I put that 3, what about the other people riding? There are 12 other riders, and they could be randomly put anywhere in the other empty spots, so we'll go 12 factorial. And then we're going to multiply that by 3 because this could happen in any of the 3 rows. Okay, so that's a bit of a tricky question for sure. For sure, that's tricky. Okay, just to explain again, we're looking for a specific scenario. This is important to understand, that we want something to happen. So what we do is we look at how many ways can that happen. And then we try to figure out what's the chances of that happening. What do we want to have happen? We want this scenario to happen. Okay, and then we have to account for the other people. So if we put this in the calculator, you know, your calculator may have a tough time handling this. I don't know if it'll work, so let me just show you a little shortcut. I can take 18 factorial and write it as 18 times 17 times 16 times 15 times 14 times 13 times 12. And the 12 factorial and 12 factorial will cancel. So that might be a little easier to put in the calculator. Okay, you get 144 over 13,366,080. All right, tricky question. You guys try a few on your own. Okay, I know these get hard. The wording is crazy. Do the best you can. We'll talk about them in class. The reality is I get confused on these too, so don't panic if you struggle on some of them. Okay?